Alright, moving on to the last section here, and this will be a lot faster than the previous section. That one took a long time. So I got 5 problems here. I think we can handle that. A quick review. Nothing new here that you guys did not see in Math 61 or introductory algebra here. So remember, with graphing systems of linear inequalities, what we have to do is we have to graph one of them, we graph another one, and we figure out what is true for both of them at the same time. So we're going to have to get like this little area right here. Usually it's going to be a little shade that's going to be in somewhat of a corner of each of these lines. So going back over here, the whole thing is we have to understand is that whenever you have a dashed line right here, dashed lines means we don't want the numbers that are on the line. We only want the stuff in the shade. How's that represented? Is represented either by a greater than symbol or a less than symbol. So a greater than symbol or less than symbol means that you want stuff only in the shade, not on the line at all. Kind of like, remember we were doing linear equations. If it was just a greater than symbol, we didn't want the number at the end, we just wanted a number that was bigger than that number. So the same thing here. So less than, we wanted only numbers that were less than, but not including that number. Okay. If we want the numbers along the line, then we have this little formula with a less than or equal to symbol, or a greater than or equal to symbol. Those are the ones that have the solid line. So that's the only thing to review real quickly here. And let's go for it. And again, if you know how to do this, you can go ahead of me. That's fine. And if you don't know this, let's do this together. Alright. Normally, if it's already in relationship to y, we think of this as y equals mx plus b. We can graph this right away. That's the whole point of knowing this. So, taking a 1 over here, there's my 1 from this point right here. And then my slope is 1/3. I think we know how to graph that, is that right? 1 up, 3 over. So from the dot we go 1 up, 3 over. It takes our second dot right here. And solid or dashed line, what do you guys say? Solid line coming across. And again, just if you want to make a more of a straight line, you can go up 1, 3 over. You can go down 1, 3 to the left, down 1, 3 to the left, just so you make a good solid line all the way across your grid. That's, you just want to have a good straight line there. Okay, and there is really 2 different ways to do these type of problems here. The book just does one of the ways here, so we'll just do one of the ways as well. No, and this is by picking a test point. And we got to pick a test point that's not on the line. And the easiest one to pick is always 0, 0. So if the line does not go through 0, 0, we pick 0, 0. It's so easy because everything turns into zeros. So picking a test point for this top equation here, the y turns into a 0. The x also turns into a 0. So really what you're doing is you're comparing that 0 to the number at the end. So true or false? What do you guys say? True it is. 0 is less than or equal to 1. So the shade is going to go towards the dot. Oof, good old yellow color there. Alright, but we do have a second equation. That's why we call it a system of inequalities. Sometimes we'll have 2 equations, sometimes 3. Usually not more than 3. Alright, so let's graph this one now. It's compared to y. Cool. Find -3 along our y. And slope is 1/3, so we're going to go up 1, 3 to the right. And again, just to make a good straight line, I'm going to fill in the dots with my slope. This time solid or dashed? Dashed. It's a dashed line. Cool. So ding, 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 ding. Cool. And we're picking a test point. We pick 0, 0 again, since 0, 0 is not on the line. Then again, all we got to do is test the y value, which is already 0 compared to the number in the back. So what do you guys say, true or false?
True.
That's true as well. Okay, so we're going to shade towards the dot as well. So we're going to shade up to the cool. All right, and what we want is we want the region that has been shaded twice, because the region that's shaded twice is the answer or the solution for both of those inequalities at the same time. So probably do this here, probably shade in a whole bunch darker. Just shade that in a whole bunch darker. When I used to teach high school, I used to torture my high school kids, of course. And I used to make them then erase. So erase all the blue stuff, erase all the yellow stuff, just keep the stuff in the middle, because that technically is the answer to both, right? Technically we should be erasing those because it's only that little middle section is the answer. All right, those are either going to go into business. I used to teach the business math class. That's sort of the next level from this class. And this is exactly, one of the chapters was doing this right here. This is where you look at profit margins to say, okay, if I have this constraint, and this constraint, and this constraint, and this constraint, what kind of profit can I still have? The example in the textbook was, that's right. We did a little farm scenario. We did ducks and chickens, or chickens and pigs or something. Ducks and pigs. And so the x value was the number of chickens, the y value was the number of pigs, and what are the constraints? There's so much room a chicken needs, right? Actually, according to California law, now there is a certain, according to the last election that we had, there's a certain space that every chicken needs. The pigs also need some space. Then you figure out consumption of food, right? There's consumption of food that has to happen. There's maybe taking care of, if you hire someone else, there's another constraint. And all those come in to sort of give you, okay, based upon that, how many ducks and how many pigs would ratio out to be our best profit for us. That's kind of what we do. When I was teaching the business math class at Fresno State, they were developing the new library. So what they were doing, they were hauling off dirt because they had to make a big old hole to put in a basement level. And so I contacted it's kind of fun. I contacted the people that were hauling the dirt out. And so I had the students try to figure out what was the best ratios of trucks to haul out the most amount of dirt for the least amount of cost. So if you think about it, they had two different types of size trucks. They had like a 2-ton truck and a 3-ton truck, right? So let's think of all the costs associated with it. Running the trucks, is that right? You got the fuel for the trucks. You got paying the workers that are hauling the dirt, is that right? You got wear and tear on the truck. You got workers' comp, right, for all the people that are working. All those things come into play to give you sort of a cost. And then so the students had to figure out, okay, which trucks, what ratio do I need in order to do this? And of course the trucks were for rent. Now you got the rental on the truck. The 3-ton truck actually rents for more than the 2-ton. So it's actually kind of fun. I think by the time we finished, we had like 16 different equations, or 16 different lines they actually had to work with by the time we figured out what would be the best or the least cost for it. Kind of fun. Okay, so 2 different equations. Let's go with 3. Okay, x plus y is less than 3. Then we got x is greater than or equal to 0. We got y is greater than, hey, they just have x's here. That's just y's over here. That's kind of weird. Okay, let's see what's going to happen here. Normally what happens with these problems, it's a lot easier to do these right here, the ones that just have x's and y's only, and then do the rest here. So let's graph x greater than or equal to 0. And hopefully you guys remember, oh, Mr. H, I remember that is a horizontal line. That is a horizontal line coming straight down along the y-axis. And x greater than 0. So which way we think we're going to shade? We're going to shade to the left or we're going to shade to the right? Yeah, notice all the x values. This is 1, 0. Right? This will be 2, 0. This will be 2, 1. This will be over here 4, 3. Notice all the x values are positive over here. This will be 4, negative 1. So the x values are all positive to the right. And again, if you need to, you can put a test point if you like. Just for the fun of it, let's test 3, 3. And when you plug it in, and you get 3 is actually greater than or equal to 0. Notice there's no y to plug in, right? Since this was not what there's just an x that we're comparing stuff. So that's true, shading off to the right for the first inequality. Next one, y greater than or equal to 0. Can you guys graph that one? I'll give you a hint, something about horizontal line. Cool, all right. So y greater than or equal to 0, that's a horizontal line along the x-axis this time. It's solid as well. And y being greater than or equal to 0 means you're going to graph up. Again, I'm going to choose a test point just for the fun of it here. That's negative 4 as my test point. And negative 4 is not greater than or equal to 0. That's a false statement. And you're going to shade up away from the point. And remember thinking about quadrants. Do you remember quadrants when you guys study this? Remember how this one is always when x is greater than 0 and y is greater than 0? So you can do it in terms of quadrants as well. This one is x is less than 0, but y is still greater than 0. Quadrant 3 is when both of them are negative. And quadrant 4 is when you have a positive x but a negative y. So you can also do it by quadrants. The book goes into that detail as well. Okay, but if we think about it, the one that we're looking at is really quadrant 1 right now, right? Because that's the one that's shaded twice. Except we still have another equation to deal with right here. X plus y equals is less than 3. All right, and this one, because it's not set equal to y, you could do that. You can subtract x from both sides, that's fine. But remember, we can do this by intercepts as well. We can think about, you know what? I'll solve it for y. You can think of if x is equal to 0, what would y be? Or if y is equal to 0, what x would be? You can do it that way. You can still solve it for y as well. So starting at 3, our slope is a negative 1 over 1. So from this point, how about we go down 1, 1 to the right. And again, if you want to keep on going further and further, that's fine. Solid or dashed? It's a dashed line now. Okay, and we got to pick a little test point. Which one do you guys want to use? 0, 0 is fine by me. Yep. Pick test point 0, 0, and 0 plus 0 is still 0, so really 0 is less than 3. Comparing that means we're going to shade towards the point. That's a true statement. All right, and the question is, what's shaded all 3 times? Yeah, it's this little triangle right here, right? This little triangle right here. And in fact, everything else gets erased except for this little triangle right here. You don't have to erase it, just color it in a lot more darker. On the test though, on the test all this would be white and then you would just have, or not filled in, and this would be filled in only. You'd only have a rectangle there. All right, let you guys try this one here. Practice, can you graph this solution set? Again, just a little practice with the horizontal and the vertical lines, just to make sure we got it. and give you some time to try it yourself. Alright, I'm going to try it as well here. So vertical line at x negative 3, and it is a dashed line. Hopefully that was in there, right? Dashed line, vertical. And then x is greater than negative 3. You can pick a test point if you like. So 0, 0 would be my test point, and that will be a true statement. So how about shading everything over to the right-hand side of it? Y is less than 4, and again, with the less than or greater than for y, it's a lot easier, right? So hopefully another dashed line. Hopefully did not put a solid line in there. And this one's pretty easy. If you have less than 4, you know you're going to go lower, right? Because the y values are all the vertical indications here. But again, if you want to just test 0, 0 just to make sure 0 is less than 4, that is a true statement. Therefore, we're going to shade down from our line. And so the shade that we want is just this little box right here. Let's see, and having the corner negative 3, 4 is the corner right here. Okay, again, some practice with vertical and horizontal lines. And one actually is a real true practice problem here. Can you guys go from beginning to end with this one here? So give you guys maybe like 2 minutes or so. Try it yourself first. Let's see if we come up with the same exact answer at the end of it all. Alright, I'm going to go for it here. So I'm going to graph the x greater than 1 first. That is a vertical line going straight down. And since it's greater than, I could pick a test point if I need to. 0, 0 would do it, but it turns out to be a false statement, so how about shading off to the right? Then I go with the next one here, solving this guy for the y value or variable. Got to divide through by negative 1. And I get myself x minus 5 would be the equation. So I start off at negative 5, my slope is 1, so I go up 1 over 1, up 1 over 1. I get to continue to do so just to make sure I have a good straight line. And solid or dashed? What do you guys say? It's a dashed line. Cool, we got 3 erasers happening here, so I'll wait just a little bit here. Alright, with that, pick a test point, and I bet you it's a good one. It's going to be a 0, 0. This is a good one. And so plug it into the original problem. And again, when you do this, you know that 0 minus 0 is still going to be 0, right? That's why we use 0 in the first place. So we're really comparing 0 as less than 5. That is a true statement. Therefore, we're going to shade towards the dot. And then we've got to do this little last one here. X plus y is equal to 5, set it is y equals mx plus b, and I get a negative x plus 5. This one starts off high, it starts off at positive 5, and we've got a slope of negative 1, so it goes down. So we're going down like this, all the way down. Solid or dashed? Another dashed line, okay. So dashed line coming through, and I get, let's see, 0, 0 is a good one to test. So let's test 0, 0 again. And again, a lot easier to test 0 because you're just comparing the two. 0 is less than 5. Yeah, that's true. Okay, cool. So that means it's going to shade this way. Again, final answer is that little dark area right there in the middle, that little triangle. So out of curiosity, raise your hand if you got the little triangle without any help from me. 1, 2, 3, 4, 5 out of 5 out of 25. Okay.
I just messed up on that one where you plugged in the true statement or the very first equation.
The vertical line?
Yep. No, x minus y.
This one?
I plugged the 0 back into, I didn't plug it back into the original equation, so I got -5.
Yeah, that was my problem too.
Got it, okay, yeah.
Yeah.
Good observation here. So when you guys do the test points, always plug back into your original equation, because that's what you're really comparing. Got it. Okay. Any other issues there besides that?
I shaded the wrong way.
Okay, okay. Got the inequality correct, but shaded the wrong way. Okay, and the last problem here, number 5. We have to do the example problem first, and then we'll actually take a look at all the other stuff here. But this is sort of going backwards here. This is a word problem. You can graph it if you like, but you should be able to go directly from word problem into an inequality or a system of inequalities. So if you think about it, think of this here. So let me read example number 5, and then we'll go on to problem number 5 here. So a college basketball arena plans to be charging $20 for certain seats, $15 for others. They want to bring in more than $18,000 from all the ticket sales and have reserved at least 500 tickets at the $15 rate. So find a system of inequalities describing all possible. Sketch the graph. If 620 tickets are sold for $15, at least how many tickets are sold for 20? Really, we're not going to get into the last problem. It's just setting up the whole system of inequalities. That's what you want to do. So let's go for it here. I don't like the order they give it to you. Well, let's do it. Let's look at the order here. So college basketball team, it's going to charge $20 for certain seats, $15 for others. So if we define a variable, first of all, we're going to have to define this. Is that right? You can't sell negative seats. That doesn't make sense. There is a possibility of selling 0 tickets as well. So right away you have this little form. X is greater than or equal to 0. Y greater than or equal to 0. Those happen right away as you're thinking about it. Kind of like the ducks and the pigs, right? Can't have -3 pigs. You're going to have at least a positive number. Once we go from here, now we go on to any other constraints. So it says, let's see, from all the ticket sales, they have reserved at least 500 tickets at the $15 rate. Now the $15 rate applies to the Y value. So we're going to change one of our horizontal or vertical lines. In this case, it's the horizontal line. Y now is going to be greater than or equal to 500. So that's sort of the end price. Cool? Or the end amount. So vertical and horizontal have changed into this right here. And once we do that, then we think about any other remaining connections between the two, and it's the dollar price. So charging $20 for X plus 15 for Y, it says they want to bring in more than 18,000. So notice 20X plus 15Y has to be greater than. So all the ticket sales together combined has to be greater than $18,000. So there it is. There's the relationship to X and Y. There's the needed standard for X, and then also the needed standard for Y. We good there? Okay, let's jump to this. Practice problem number 5. So how would the graph in figure 16 change if we reserved, this is from the matched problems now. What would happen, or how would it change if only 300 tickets are reserved at the $15 rate? So let's take a look at this one together. And again, we're just setting up those inequality markers here. If we got those, we're doing great. So the $15 rate, remember that applies to the Y value, right? And so in this case, we're going to say this. We're going to say X is still greater than or equal to 0. That did not change. If they only reserve 300 tickets for the $15 rate, then we have Y is greater than or equal to 300 instead of the 500. And then we still have a $20 ticket and we still have a $15 ticket. So 20x plus 15y has to be greater than. And let's talk about it. Is it greater than or equal to? They want to bring in more than $18,000. So they'll be just a greater than symbol. We good? They want to bring in more than, because the example problem says more than. So maybe their, how much the arena cost and everything else was $18,000. So that means this will be their sort of their, it's called the break-even point in economics. This is when you're finally making money. That's okay. So our real quick here, just to finish off the math, the match problems here. So how would the graph in Figure 16? This is from the textbook. So connecting it to the graph here, how would this change if we only reserve 300 tickets at 18? How would the graph change? Absolutely. Remember this one? This one's at 500 right now. It's the horizontal line. And so the horizontal line would move down to y equals 300 from y equals 500. That's, they're just sort of connecting the graph and the equations here. All right. And you guys have to tell me one little extra piece here. You know how the book could actually be wrong sometimes? So you guys get to stare at the graph and tell me, Mr. H, what is wrong with this graph? Say again?
The line should be not a solid line.
Ah. You sure? Let's go for it. Y is greater than or equal to 300. You're close, Nick. You're there. Almost. Think about it.
Red line.
It's the red line, right? The red line, this is the relationship coming down this way, right? So this red line, that's the one that should have actually been dashed if we're looking at greater than 18,000. But this is a pretty good, right here, this is a pretty good area to look at cost effective. So especially when you're looking at the corners right here, we say the maximum or minimum are going to occur at the corners. So then the minimum they have to sell is roughly about 500 tickets, and they'll at least meet their quota. So anywhere in here or anything above these two lines, that's where they have met their conditions here. Okay, so let's stop here for now. Let me do this real quick.